Okay, class 12. Today we are going to discuss something that you already know actually. Okay, you've done in class 10 itself. I thought of giving this as a DYT, but still I just want to very briefly go through it. Okay, so the topic is electrical energy and power. Now see, we have a circuit over here, the simplest kind of an electrical circuit. Okay, so we have a battery, okay, to which is connected is a resistor R, okay, forming a closed circuit. So say for example, current I is flowing through this circuit, and this current I flows for time t. Okay, current I flows in the circuit for t seconds. All right, so when current is flowing, we know current basically is a flow of charge. All right, so if current I flows for t seconds, then the number of charges that are being transferred in this circuit, say for example from point A to B, let us consider these 2 points. Okay, so the number of charges that is moving in time t from point A to point B, that is through this resistor R, is given by Q, which is equal to I into T. Alright, since I is the current flowing for t seconds, so the charge is flowing from A to B in time t is IT. Alright, so we know this. Now, for a charge to move from one point to the other, work has to be done. Okay, work is being done by this external power source, of course. The battery is doing work in here. So the work done by the battery to move charge Q from point A to B in time t, okay, the work done, that is exactly what I've written over here. Work done to take charge Q from point A to B is given by work is Q into V. Because we know from the definition of potential, potential is work per unit charge. Okay, I don't think I need to go on explaining this. So from here we get work is charge into potential or potential difference. You know potential and potential difference are one and the same thing. So potential where V is the potential difference between point A and B. Okay, so the potential difference between point A and B, that is across this resistor. The potential difference between the two ends of the resistor R is V. Okay, so the work done to move charge Q from point A to B is given by Q into V, where V is the potential difference between points A and B. Value of Q from here we get W is VIT. Okay, work is VIT. So this is the amount of work that is needed to be done when a charge moves from one point to the other. All right, now since we have a resistive circuit in here, okay, now see, I have shown a resistor to be here between points A and B. Okay, instead of a resistor we could have had anything. We could have had a capacitor in here. Okay, instead of a resistor we could have any other electrical component like an inductor. We'll talk about inductors, you know, in the later half of current electricity. Okay, so we could have any electrical component in here. We could have had a resistor over here, we could have a capacitor in here, we can have a inductor in here. All right, now whatever be the electrical component between point C and B, this equation, this formula, let me say, okay, I don't like this word formula, but still this work done VIT is true for any electrical component in here. Now since I have shown the electrical component to be a resistor in here, strictly for resistive circuits, for a resistor, we have V is IR. Remember, this we get from Ohm's law, and this is true for a strictly resistive circuits, which are ohmic devices, remember. Okay, this is not true for any other electrical components. We could have had a diode in between points A and B. So this formula W is VIT is true for a diode. Okay, but this is not true for a diode, remember. This is purely for a resistive circuit. So that is why I've written V, since V is IR for a resistor or for a resistive circuit, then W, which is VIT, okay, can be written as I squared RT, substituting for V from here, which is also equal to V squared by R, substituting for I from in here. Okay, V squared by RT. So these two things, this equation and this thing, these W is I squared RT or W is V squared by RT, these two are strictly for resistive circuits, remember, whereas this is the more general thing. the expression, more general expression for work done. All right. Now, power we know is the rate of doing work, okay, or the amount that how much electrical energy is dissipated into other forms, okay, is what is called power. That is also what is called rate of doing work. Okay, so rate of doing work we know, so power is W by T. So dividing work by time, we get P is VI from here. Okay, so this expression for power is true for any electrical component. Okay, whereas these two, P is I squared R or P is V squared by R, these two expressions are true only for resistive circuits. Remember that. Okay, now these things you've studied in class 10 itself. Also, unit of work done or energy is joule, which is also called watt second, because watt is joule divided by second, so joule is watt second. So other units for work or energy are watt hour, okay, kilowatt hour. All right, then unit for power is watt, which is also called joule second. Remember that. Now this thing, this you already know again, okay, commercial unit of electricity consumption, or all right, which is kilowatt hour. Kilowatt hour, this is also called board of trade units, BOARD, board of trade unit. You studied about this in class 10 also, BTU. Normally speaking, kilowatt hour or board of trade unit is simply referred to as a unit. Okay, you must have heard your parents say यो महिना त 50 युनिट उठेछ, यो महिना लास्ट महिना त 30 युनिट मात्रै उठेको. You must have heard something like that. Okay, so that unit is nothing but kilowatt hour. Okay, so you need to go and check what is the definition for kilowatt hour. Okay, in which case you will get an idea about what is the amount of energy consumed. एक unit उठ्दाखेरि चाहिँ what is the amount of energy consumed, you will get an idea about that. So go and check the definition, and also go and check the relationship between kilowatt hour and joule. Okay.